Okay, so Module 4, Investigation 9, problem number 4 is where we are now. This is the alpaca problem. It says read the alpaca problem from Module 4, Investigation 4, but we don't really need that for what we need to do today. A farm in Canada had 218 alpaca on January 1st, 2004. After 8 years, the alpaca population decreased to 187. Assume the number of alpacas decays exponentially. So it says define a function that expresses the number of alpacas in the farm in terms of the number of years since 2004. So I want a function that has the alpaca population as a function of the time that's passed since 2004, right? And so what I'm looking for is, again, I'm looking for the rule for that function, which means I need an initial value. Well, that part's easy. The initial value is right there. And then I need a growth factor. Okay, well, the growth factor would come from dividing a population by the previous population, right? Well, we have a population and a previous population, but the problem is that this right here would give us the 8-year growth factor, right? So that's 8 years that the population decreased to 187. Oh, I'm very sorry, pardon me. That is not what I intended to do. Let's go back. Thank you. Anyway, so this is the 8-year growth factor, and that's not what I want. I want the 1-year growth factor so that I can then raise it to the t power and I'll have it. That's not what I meant to do at all. What's happening? Okay, so this guy right here, to reduce it from the 8-year growth factor to the 1-year growth factor, I can do that in a couple of ways. I can either take it to the 1/8 power, or I can take the 8th root of it. And I think what I'm going to do is I'm going to put this inside a radical. So I'm going to take the nth root, so the 8th root of this ratio. Now, if you've done this already on your paper, you probably have like an approximated value. There's nothing wrong with that. In fact, let's figure out what that would be. So if we go back over to Desmos, if I go functions, nth root, there it is. If I go the 8th root of 187 over 218, whoopsie, then I get 0.9810. So I could say that this is approximately 218 times 0.9810 raised to the t power. That would be perfectly fine. So you don't have to worry about that precision too much. So this would take care of part A. Part B says use the function that you defined to estimate the number of alpaca on the farm in 2013. Well, if I take this function, in fact, let's just take the approximated one just for right now. There's a lot of things that we can do to keep exact values. I'm not worried about that right now this second. They're saying, when is this population going to reach, oh, no, they're saying, what is the population in 2013, right? So what we're looking for there, so 2013 is how long after 2004? Well, it's 9 years after. So I'm going to call this f of 9, and I'm going to find f of 9 by just plugging that in, right, f of 9. And so let's find that. So I can take this right here. In fact, I could use this, now that it's in here, I could use this by saying 218, oopsie, 218 times this amount right here raised to the 9th power, and it would give me my 183.4487. So we've got 183.148, nope, 4487, pardon me. And so, of course, we can't have a partial alpaca. So estimating the number of alpaca on the farm, I would approximate that by rounding down, no matter what the decimal places are, because rounding up, I'm going to fall short. So I want to make sure that I don't do that. So I'm going to say approximately 183 alpaca in 2013. Whoopsie. The last one says determine the year when the number of alpaca on the farm was 165. So this we can take our function and say, when is it going to be 165? That's what we're trying to figure out. And so we can solve this the way we would solve the other exponential functions that we've used. We can first put it into a form that will let us convert. So 165 divided by 218 is equal to this 0.9810 raised to the t power, and then we can switch that into logarithmic form. Go here's our log. Our base would be the 0.9810, and our input value would be 165 over 218, and we would try to figure out what that value was. So let's go over and figure that out. So if we take a logarithm, log base, what was it? 0.9810. Oopsie, didn't save my place, did it? Oopsie, come on. Oh, that's not right. Let's try that again. 0.9810 of, what was it? 165 over 218. And that's 14.5208. So that's 14.5208. And so I would need to acknowledge that that is a partial year. So I'd have, I apologize if you can hear the instructors talking outside my office door pretty loud. Anyway, so if t equals 14.5208, oopsie, that's not what I meant to do. That's weird. T equals 14.5208. So between 14 and 15 years after 2004, this would be interpreted as either during 2018 or in 2019 as like the beginning of the year. Okay, so that takes care of problem number 4.